Alright, so today's lesson, we have already talked about exponent rules before. We're going to look at some more complicated examples. Now, before we get into the complicated examples, let's refresh our rules. So, let's see. If I have a base to some exponent times that same base to a different exponent, remember that was the same as adding our exponents. And if I wanted to take a base to some exponent and divide by the same base to an exponent, remember that means that we subtract our exponents. If I have something to the exponent 0, remember that comes out as 1. So that would be like, I don't know, say we have 6 divided by 6, right? Cancel them out and we're left with 1. If I use my dividing rule, that's the same thing as 6 to the exponent 1 divided by 6 to the exponent 1. 1 minus 1, that gives me 6 to the 0. Right? So they're the same. So that means 6 to the exponent 0 is 1. Okay, we had a few other rules. We had if something was inside bracket, so there, to a new bracket. Remember, then we had to multiply our exponents. So we had to multiply our exponents. And am I missing any? I think that's all of them. Oh, and watch out for your brackets. Okay. So if I have it written like this, that exponent is only being applied to this base here. It is not touching the exponent, or the negative. If I have the negative inside, then it touches. So these are not equal statements. They're not equal. Okay? Alright, let's do an example. So just like last week. Okay? We're just going to do one just like last week. So if I gave you 2 to the exponent 4 times 2 to the exponent 10. The 2's are both the same, which means that that's my base. And because I'm timesing, I want to plus my exponents. So I want to do 4 plus 10, which would give me 2 to the exponent 14. And all I'm doing right now is just simplifying. I don't have to calculator. Good? Okay, now how would that example look if I used something different as my base? So this time, let's use the letter y. Y to the exponent 5 times y to the exponent 7. They're both the same, so my base is the same. And when I've got the same base and I'm multiplying, I just add my exponents. So I'm going to take the 5 plus the 7. So my new exponent is going to be 12. So my simplification for this one is just y to the exponent 12. So it's no different than when I had numbers and I was simplifying. I still want to keep my base together, and I have a new exponent which I got by adding the other ones, and I chose adding because they were multiplying. Alright, let's try this again with division. Okay, let's simplify division. So let's see, I don't know, let's pick 7 to the exponent 6 divided by 7 to the exponent 2. Well, according to our division, and that's all a fraction is division, my rule is to subtract my exponents. So let's do 7 times 6 minus 2, which gives me 7 to the exponent 4. Okay. Let's do the same thing with the letter. This time, I don't know, let's pick v. V to the exponent 12 divided by v to the exponent 3. Well, v is my base, my two exponents, and I'm dividing, which means I want to subtract my exponents. So I get v to the exponent 12 minus 3 is 9. Not bad. Let's try some more. Alright, for e, let's do our power of a power rule. So let's say I've got, I don't know, 10 to the exponent 5, all to the exponent 20. Sure. Well, my rule says that when I have an exponent outside of another exponent, I got my brackets, I got this guy happening, I'm going to multiply my exponents. So that gives me 10 to the exponent 5 times 20, which means that's going to equal 10 to the exponent 100. Yeah, that's not fitting in your calculator. Okay, let's try it with a letter. Let's pick a letter. E, F. All right, let's use X. X to the exponent 12, all to the exponent 4. Same rule applies. So I have this lovely 12 inside. I have the 4 outside. My rule says times. So I keep my base, which is an X. 12 times 4 for my exponent. So I'm left with X to the exponent 48. Okay, that's not too terrible. Not too terrible. Let's do one more. What if I have 2x, y, z, bracket, 0? Well, because that's outside the bracket, that includes everything in the bracket, and anything to the exponent 0 is 1. So that just equals 1. Because it's everything. It doesn't matter what's inside the bracket. Nope, doesn't matter. As long as it's bracket to the exponent 0, your answer is 1. Good. Okay, so I'm going to take what we just did in that last example, and I'm going to expand it to a new rule. Okay? In this rule, it's kind of a take on well, not even, well, yeah, that one. So what's going to happen is I've got A, B, C inside, all to the exponent, whatever. Well, that exponent outside here, that hits everything. So that exponent is going to come in and it's going to land on the A. It's going to come in, it's going to land on the B. And it's going to come in and it's going to land on the C. So it's going to come in, and that means A gets it. It means that B gets it. And it means that C gets it. So I've got to expand out my brackets. Expand each base gets exponent. Okay? And it doesn't matter if I have it set up like this or if I have it set up like a fraction, A over B. As soon as I put an exponent outside, it has to come in and it has to hit each base. So that one becomes numerator to the exponent over denominator to the exponent. Okay? And I can't simplify that any further because they are different bases. Should we try some examples with that one? Let's try. Let's see. Examples of new rule. So let's say I've got 3x y to the exponent 2. Let's keep it nice. Well, that 2 is going to come in, that exponent's going to come in, it's going to land on the 3. So I'm going to get a 3 to the exponent 2. That exponent's going to come in and it's going to land on the x. So I'm going to have an x to the exponent 2. And it's going to come in and land on the y. So I'm going to get a y to the exponent 2. And to finish off, I would probably evaluate my 3 squared. Well, 3 times 3, because that's what that means, is 9. X squared, y squared, and I'm done. I can't go any further than that. That's a squared, by the way. That's a 2. Did I make it worse? Probably. Okay. Let's try an example of the fraction. So if I had the fraction, I don't know, 3 over 4 to the exponent 2. Sure, we don't have to get too complicated. That exponent 2 is going to come in and it's going to hit my numerator. So I get a 3 squared over, it's going to hit my denominator. So I now have a 4 squared. So I've now simplified using my rules. And then if I evaluate, well, 3 squared is 9. 4 squared is 16. And there we go. All right, let's try another one like this, only let's make it a bit more complicated again. Let's say I have 2 over 3 to the exponent 4 divided by 2 over 3 to the exponent 2. Well, there's more than one way you can do this. The easiest way to do it is to get rid of this part first. And when I'm dividing, notice I have 2/3 and 2/3. Well, that's my same base. So my base, in this case, is 2/3. So let's use our rule. So my base is 2 over 3. And when I'm dividing, remember that just means we subtract our exponents. So, subtract our exponents. And what's that leave us? 2 over 3 to the exponent, 4 minus 2 is 2. Nice. And then to finish it off, now we can bring this exponent in, hit our numerator and our denominator. So you've got 2 squared over 3 squared. Finish it off. The whole thing is equal to 4 over, because that's 2 squared, 3 squared, which is 9. Nice. Okay, to finish off our examples, what happens if I combine letters and numbers? How are we going to handle that? Well, let's think. If I have, let's say, 6x squared divided by 2x. Okay, so I'm going to treat my numbers and my letters differently, okay? And in this question, we've got a bracket there and we've got a bracket there. I should have probably put those in the question. So I want to do this whole term, 6x squared, and I want to divide it by this whole term, 2x. All right, let's see. Well, if I put that 6x squared in my numerator, and I put that 2x down here in my denominator, it kind of groups things, wouldn't you say? So I kind of have this 6 and the 2 are kind of grouped. Well, I know how to divide 6 divided by 2, right? I know how to do that. And I kind of group my x's together. And we now know that rule on how to do x squared divided by x. We can do that. So why don't we do that? Sure. 6 divided by 2 we know is 3. And when I'm dividing my letters, let's see, when I'm dividing my bases, I'm going to subtract my exponents. So that gives me an x to the 2 minus, oh, do we remember what the exponent is if there's nothing written? Remember it's a 1, right? X is the same thing as x to the exponent 1. So I need to do 2 minus 1. Final answer, 3x to the 1. You don't have to write the 1. You can leave it as 3x. Should we try another one? Probably. Let's try this one. So I've got 50x to the 4, y to the 6, all divided by 10x cubed, y squared. Well, let's group things up. So deal with the numbers. Well, 50 divided by 10, that's just 5. Okay, we're just reducing that fraction. x to the 4 over x cubed while we're dividing, which means I subtract my exponents. So I've got x to the 4 minus 3. And then let's look at our y's. And I've got y to the exponent 6 minus 2. Final answer, 5. Let's see. X to the exponent 4 minus 3 is 1. 6 minus 2 is 4. So there you have it. 5x, y to the 4th. Well done. Okay, what happens if I have a bunch of letters and we're multiplying? Okay, let's do a cubed, b cubed, and let's times that by, I don't know, a to the 6, b to the 4. Sure. Well, how about we group things together that are the same? Remember when we're multiplying, and that's all we're doing here is multiplying. There's a multiply in here. There's a multiply there, even though we don't write it, but they're side by side. There's a multiply there. We don't normally write it, but it's there. Well, I can change my order. So I can do a to the 3 times a to the 6. I can put those out front. And then I can do my b to the 3 times b to the 4. Sure. And then, just like what I did with my fractions, now that I've got these guys together, I can use my rule. So when I'm timesing, remember we plus. So I have a to the 3 plus 6. Let's look at our b's. Remember we're multiplying, so let's add our exponents. So we have a b to the 3 plus 4. Final answer, a 3 plus 6 is 9. B 3 plus 4 is 7. Ta-da! Alright, so I'm going to call it quits there. 17 minutes is certainly long enough of a video. So you go, questions are posted, give them a try, see how it goes. I should see work for everything, not just final solutions, please. And when you get stuck on something, talk to somebody, send me an email, put a little question mark, and we'll figure it out. Good luck!